know what we're going to do? Problem of the day. Let's check it out. Getting in the mood. I mentioned Halloween. Let's mention it again. We have a jack-o'-lantern with a triangular nose, height of 3.4 centimeters. Now, that's not the jack-o'-lantern. That's the nose, all right? And the nose has a base of 2.5 centimeters. And then, you know, when you're cutting out the pumpkin and decorating those jack-o'-lanterns and stuff, you've got a thickness also. We're going to give it about 2 centimeters. Now, everybody understands centimeters are not inches. In fact, it takes about 2.54 exactly to make an inch. So we're a little bit over, we're not quite an inch with the thickness there. And we're just right at an inch almost for the 2.5 centimeters and a little bit over for the 3 4/10 centimeters. So think of that in that respect. It's a little three-dimensional piece. We want to figure out the volume of that removed piece. So hopefully that helped you see it. Let's see if we can visualize it even better on the paper here. I went ahead and developed a little old triangle here because that's the first thing we got to worry about is what's the area of that triangle. Then we will tackle the depth problem, all right? Because what it is, excuse me there, the whole idea behind volume, you got to remember, is its area is going to equal, what is this, 1/2 base height. First of all, let's make that note. And what's going to happen is to find the volume, we're going to take this depth, which I'm going to call depth. We could call it also height. But depth times the big A. A is the area of the triangle, all right? So that's what we're going to be looking for. So we've got to have that, and we already know the depth is 2 centimeters. That's the thickness, if you will. So we're going to find out what kind of, when you go in there and cut it out with a knife and you pull it out, how much pumpkin did you pull out? Now you say, Ernie, doesn't it kind of round? It rounds a little bit, but if you remember we'll get there right. Your faces have a little kind of a, I don't know, more of a, not a curvature like you see when it gets around the edges of them there, but it is fairly good, but it's not an extreme curvature. So we're going to play the volume. We're going to assume a little bit there, but we're going to play it as if we can run those things through there. We're going to look at a volume of a triangular prism, it looks like. So let's see what happens. We have, first of all, let's pull in some numbers here. We have a base, we're going to call our base right here, and then we're going to drop that altitude right down the middle here. And altitudes, by the way, make perpendicular segments, in case you're wondering. And we have this coming together. You know, when you cut them out, you always hope it's going to be an isosceles triangle. You always try to make it look pretty good. Or you might do a nice little circle and stuff. But it's funny how those pumpkins never always seem to make it exactly perfectly even. But we're going to go with this as being, what did they say, 2.5 down the bottom here. And then we'll come back and put a 3.4 here at the altitude piece. Now, remember what I said, base times height. Base, that's going to be, so let's go to our area here. We're going to have area equaling 1/2 of 2.5 times our 3 4/10. That's not so bad. That's not really hard to do, is it? We can take half of the 3 4/10. That makes 1 7/10. And probably then even still, we all want to go back to, let's see what's on the calculator. Let's check it out there. So first of all, let's just do what it says. We're going to say 3 4/10. And I'm going to go ahead and multiply it by 2.5. Those are my centimeters. I'm getting square centimeters that way. By the way, we want to get cubic centimeters on this little volume piece here. Let's see. We want to, I think we want to hit a time sign. Somewhere I did not quite do that. Let's clear those. Let's try that again. How about it? 3 4/10 times, here we go, 2 5/10. Interesting. And that's what we're looking for. All right, we're looking for 8 5/10. But keep in mind, that's going to be, we're going to need to take half of that to get our area. So let's take half of 8 5/10, see what we get. We'll just take that value there, see if we can get this to work right. We'll multiply it by half, which is 5/10. And we got 4 1/4 literally here. All right, now remember, these are square centimeters. We're going to take this little number right here, and we're going to go back up to our formula right here. So we're going to, that's got our area of this triangle. all right, the area that we're seeing of the triangle. We now need to take our depth. Now, I gave you an easy depth. You notice that? It's going to be 2, and this is really going to be nice, but that's okay. It's still using the formula here as we go with it. So I've got the depth, which is 2, times our area of the triangle, which we said is what? 4 25/100, or 4 1/4, or as we like to call it, 4.25. And you know what happens when you multiply by 2? You get right back, almost right back where we started from. We get back to where the area is. But important to note here, we do not have square centimeters anymore. These are cubic centimeters. So units are very important because we're now in 3 dimensions basically. Now once again, we're fudging a little bit on this thing, but it's pretty close, and we're using that prism look as we cut out our little triangle because there isn't that much curvature going on there, but we keep that depth pretty constant. It'll work out for us. So there you have it. Problem of the day with a little bit of a jack-o'-lantern Halloween theme.